Your honest, no BS, non-salesy conversation about enterprise data management presented by Data.World with tasty beverages in our hands. I'm Tim Gasper, longtime data nerd, product guy at Data.World, joined by Juan Cicada.
Hey, Tim. I'm Juan Cicada. I'm the principal scientist at Data.World. And as always, it's a pleasure. It is middle of the week, end of the day, and time to finally have a drink and chat about data. And I'm super excited. Doris Lee here is today, and we've been trying to get Doris on the show for a long time. We finally met like over the summer at Snowflake, and I've been following a lot of the stuff that she's been doing because it's like I love it when we have academics who are like doing really awesome stuff and they're pushing it to startups, and it's just more. We need more of this stuff, I think. Doris, it is super awesome to have you, former CEO and co-founder of Ponder, which was recently acquired by Snowflake last month. How are you doing?
Good, Juan and Tim. Super happy to be here. Super excited for our conversation today.
Fantastic. Let's kick it off. What are we drinking and what are we toasting for today?
Oh, well, it's early afternoon here in Pacific time, so it's just a cup of tea for me on my desk, and I wish I was sipping a glass of pina colada on the beach, but not today. Not today. But yeah, I'm toasting to a great conversation ahead of us, and really excited to chat with you all today.
Awesome. Well, excited about it as well. We actually have our all hands week over at Data.World. So the whole company is in town in Austin, Texas, which is a lot of fun. That means the bar cart is full and ready. And I am drinking a tequila and blackberry lemonade soda. And then what are you drinking?
I'm drinking just a traditional good old highball. Just whiskey and soda, and it's a Johnny Walker Red and some Topo Chico. And this is nice and refreshing because we'll have a lot of fun activities this week. So, So cheers at getting people together and for great conversation.
Yeah, cheers, Doris.
Cheers.
All right, so we got our warm-up question today. So today we're talking about how to make data science more accessible, more intuitive. So what is something, it could be either a product or a service that you find really intuitive and usable? Or you can flip it around, like something you don't find intuitive and useful.
Something that's terrible.
But it is needed.
Yeah, I think this is like completely not data related, but like Slack I just love using Slack. Like we use Slack as part of Ponder. Slack is amazing. And I think what Slack did was it just like kind of raised the bar for what we thought of like workplace messaging. And like workplace messaging was just like emails and like, I don't know, like Microsoft, like I don't even know, like Outlook or something. It's just this like really boring like communication channel, and I think Slack had just made it really fun for people to message each other. It was like a huge part of our culture, having like emojis and everything, so it just made it really fun. I don't know if you all know about the story behind Slack, but I think it started off being like these founders trying to create like a gaming company, and then at the end of the day they were like, oh, this is like a great like messaging platform, and they like pivoted the whole company to be like a messaging platform. So it's super cool.
Now that you say that, I'm like, yeah, that's actually pretty. I really enjoy Slack. I mean, I think there's people who are like, there's different sides. There are different sides of the fence and stuff, but I like it. It is very intuitive.
Yeah. Well, Data.World's the first company I've worked at where actually I think we spend more time in Slack than on any other communication medium, which I find very interesting.
Mm-hmm.
So,
interesting, but you're not a big fan.
Well, I don't know. Well, I mean, Slack is all real time. There's some days where I'm like, I need to turn this off. It's too much, but it is very intuitive, right?
Yeah. How about you, Tim? Do you have a product or service you find really intuitive?
So I was thinking about this question, and I was like, oh my gosh, how am I going to answer this question? This is sort of a cop-out answer because, I mean, we've been talking about it almost every week, but like I've been really astounded by how many different ways that I can use ChatGPT. Like natural language, like I dig it. Like I want more natural language. Like the other day I was like, I was emailing somebody and they were like, hey, like I'm available this time to this time and this time to this time and this time to this time. And it's all UK time. And I'm like, oh my God, I need to do all the translations, right? And I'm like, I wonder if I just copy and paste this into ChatGPT, is it going to translate the whole thing? And of course it did. Like, of course it did. So anyways, I love natural language. ChatGPT's been great.
Yeah, that's it. I was thinking about this as like, what was something that wasn't intuitive and usable that it did become? And I think my answer is about maps. Like now your Google Maps and all that stuff. I remember the day before it was like printing it out on MapQuest and stuff like that. That really changed the world.
Yeah. Now you can only get lost if your cell connection is bad, right?
Yeah. All right, let's kick it off. Doris, honest, no BS. How do you make data science accessible? What does that even mean?
Yeah, so I think the funny thing is like data science has seen a lot of like shifts and changes over the past, decade or so. Like I don't know if you all remember, like I think like early 2010-ish, like Harvard Business Review, they had this like famous article that talked about how like data science is like the sexiest job in like the 21st century, right? Like people kept talking about that. There was a huge buzz around like data science being like a huge game changer. Now, I think it like data science as a field has evolved a lot since then. Like we've seen tooling, like and just the field evolve. And at that time, like the 2010-ish era, like it was still very nascent. Tooling was not standardized, and essentially, like data scientists had this really hard job of like, hey, you need to be an expert in your domain. So maybe that's finance, maybe that's biology, like genomics, whatever is your domain. You need to be an expert in statistics, machine learning, programming. You need to know how to program. You also need to know how to work with big data. So oftentimes that means you need a CS degree or you've done software engineering in the past. And so like where do you even find these like unicorns or like these really rare unicorns in the market? Many of them typically also have like a PhD in the sciences, like that could be astronomy, physics, genomics, or whatnot. And so I think that when we think about data science at that time, it was a field with a very high barrier of entry. And a lot of my work over the past, 5 years and even before then was really around like how do you lower that bar? Like how do you make it easier so that anyone can kind of do data science, explore their data, and really understand what's going on with their data? Because I think there is a tremendous amount of value for domain experts, people that are, specialized experts in their domain, uh, and to give them the power of working with data, because they can see the data in a lens that, like, us as just like, software engineers or like computer scientists, like we see it in a different lens just because we aren't in those domain. Like we're not a genomicist, we aren't a domain expert in finance, for example. And so that is like one of my dreams is like, what if everyone in the world, whatever their specialty is, can work with data? And so, yeah, like it was probably a very long answer, but basically when I think about like accessibility in data, it's about like enabling that like 99% of the population to be able to work with the data.
I love that. I mean, I think that's the dream, right? Is that we don't want people to have all this specialized technology and tooling knowledge just to be able to answer questions about their business or about how things are going. And I do wonder though. Do you see a difference between kind of lowering the barrier for data science versus lowering the barrier for business intelligence or more basic kind of questions for data? Do you see those as two different things, or are they actually kind of the same thing when you look at them?
Yeah, I think Tim, you're definitely right that there's kind of this spectrum of like when we talk about data science, BI. I think all of them are kind of in the same spirit of like, hey, how do we allow more people to access, understand, visualize their data? Actually, early on in a lot of my PhD work, I focused a lot around what you just talked about, which is like low code, no code kind of use cases. So your standard sort of BI charting tools where you have an interface, you're clicking through, various different buttons to create a chart. And I think, one of the best examples of that, two tools that comes to mind is like spreadsheets. Like Microsoft Excel did a really great job in, converting like raw, boring numbers in a grid to something that you can actually work with your mouse clicks and everything, and create powerful formulas, calculations. So that is like in my sense, like a very successful tool that enabled like a large number of like white collared sort of like anyone who is working on a computer to be able to work with their data being like any like table of numbers. The other tool that did a really good job in this is Tableau and BI tools. Tableau not only said, hey, we have this grid of numbers, let's convert it into very beautiful charts that actually tell a story. And you don't need to know any programming languages. You don't need to be an expert in charting. You can use Tableau, point and click, drag and drop, and bam, you have a visualization. So those I think are like early examples, again, around over the last 10, 20 years where data has become easier and easier for people to work with. And I think now we're in an era where, people are looking for more complex analysis, forecasts, even running machine learning on their data. All of those things I think are like part of these like more advanced machine learning and data science use cases. And I think we're in a new era where like we need better tooling to allow the 99% the spreadsheet users, the BI users to be able to use and access those technologies.
Yeah, let's take the next step, right?
So you started off kind of giving like the original data science, this data scientist definition, right? It's like this big unicorn with its overlaps. I mean, statistics, programming, big data, machine learning, experts in, right? So how 10 years later, like what is the definition of a data scientist today? I mean, it's not that big, it's not that unicorn, right? So what is it then today? And how has that evolved?
I think the line is definitely blurred between what we traditionally called like a business analyst or like a data analyst to data scientist, and even like, the new term like machine learning engineer. Like, there is a spectrum of like what people are doing across all of these different fields. I think as we sort of lower the bar in terms of what it takes to be doing data science, we're going to see more of the blurring of the line. One example of this is actually in a lot of like financial use cases, like financial, banks, quants. People aren't moving away from spreadsheets, but they're spreadsheet users, people who are typically spending like 90+% of their time in spreadsheets. They're now learning Python. They're now learning data science so that they can do more with their data. They could do time series forecasting. They can do, summarization of their data and so on. So that's one example of where I think in the future, like if like data science do become more and more accessible, like we're not going to have the title a data scientist. Everyone is going to be a data scientist. Like you might be a biologist. Like your title might be like, hey, I'm a medical doctor. I'm a biologist, but you are a data scientist too.
Interesting. So maybe the data science sort of role was born around like this specialized skill set originally, right? And so folks that could learn that skill set could step into those shoes. But you mentioned some different words here. You mentioned like statistics, programming, big data, machine learning. Like is the goal to, if as each one of those things becomes more accessible, then this idea of the data scientist becomes less unique. You're imbuing the power of the data scientist onto the business analyst, onto the programmer.
Well, to add to this, is this? I mean, I'm going back to the word accessible here. Is it really about the tools that are lowering the barrier? Is it, or is it more about like some of the education, or is it, I mean, one or the other? Because I think like we've been using spreadsheets forever, right? And then you can argue, people would argue like, well, I'm doing data science. Well, but you're doing things in the spreadsheet, but you are still kind of generating the same outcome. I happen to using a spreadsheet and I'm going to call myself a data scientist. Like, that's fine, right? I mean, that was a tool that I used. And I guess more and more tooling is kind of making it accessible, but also how much of it is actually the training versus like understanding how to go do things with data. I'm curious to get your thoughts here.
I think it's definitely a mix of both. Like you need both the education, the kind of the knowledge around like how do you think quantitatively, how do you reason with data, what are common statistical fallacies that you should be aware of when you're presenting data. Like all of those educational elements are super necessary. Even when we have like automated tools, like that education, that training is still like extremely important. And then I think the other aspect of this is when we talk about when I think about accessibility and in particular like how it pertains to my work, it's often around if you take all of the keywords I talked about earlier, more around the programming aspect, and also the aspect around like, hey, you don't need to have like a PhD in computer science to be able to do that. So more around like the computing aspect, and how we can lower the bar there, because it's pretty rare for someone to have like both a PhD in biology and a PhD in computer science. And so the goal is that like, how can we allow everyone to be able to work with their data?
One of this I see is like a synonym basically of data science. When you think about tooling, technology, computing, is Python. So how is that like still to do data science, you at least need to know Python as a language to go do things? And actually, to kind of broaden out the question is, per your perspective, like how have you seen something like Python come in and like change the data science landscape?
Yeah, Python, Python is a really interesting, has a really interesting relationship with like data science. I think it was interesting because Python was one of the first languages that I learned for programming. And it was just so accessible in the sense that like, if you ever learn like other programming language like Java or like C++, like the reason why Python is really special here is that like in Python, it's very high level. It's a very high level language, right? It's like, so you don't have to really think about types or memory allocation or any like low level details about the computing stuff. But it allows you to really focus on what you want to do with your data. And you're not really like boggled down. You can just specify like, hey, this is what I want to do. And this is really important as it relates to data science, because when you're creating like data pipelines, data workflows, and so on, you're always trying to like iterate really quickly. No one ever like writes like end-to-end data science workflow just like from scratch without ever trying things. You're always like running stuff and then like going back, changing something, and then running stuff again. So there's a bunch of like trial and error. So data science is inherently like very iterative. And so Python has some really nice element that couples well with that. One is that high level aspect that I just talked about. I think the other is like the fact that it's very interactive. And the interactive aspect actually comes from the fact that Python is an interpreted language, which means that when you're running Python code, it's not like Java or C where you have to compile it first and then run it, compile it first and then run it. So there's kind of like this step between like compilation and like being able to see your results, right? In Python, because it's an interpretive language, you can just like run it. You can even run one line at a time. So like you run a line, you look at your results, and then you run the next line, you look at your results. So it's very easy to actually inspect your result and then figure out like, oh, okay, this is the next line of code that I want to write. And so that has led to the development of things like IPython and Jupyter notebooks, which is a very interactive development environment for data scientists to be doing data cleaning, transformation, all the way till visualization, all in like a single development environment. So I think kind of those two aspects that are very unique. I mean, it's not completely unique to Python, but it's one of the kind of the selling points of Python, has made it very attractive for data scientists to say like, hey, this is a really easy way to get started, especially coupled with that fact that we talked about, which is most data scientists or the people that want to be working with data aren't really coming with like traditional like computer science background, which means that if a language like Python is really easy to pick up, it makes a great kind of starter like intro to data science or intro to data science course, which is what we've been seeing in the last 5 years, which is a bunch of these data science boot camps, Python boot camps aimed at upskilling and helping people get into data science.
Yeah, I like that example you gave of quants at a bank, and maybe you know how to use a spreadsheet. Learning Python now can take what you're doing to the next level, and it's clear that notebooks have become very, very popular, and the popularity of Python obviously has a lot to do with that as well. I think it's interesting how there's sort of three trends I kind of see happening, and I'm curious, Doris, what your thoughts are on this. There's data science features being added into places like Excel and Tableau and things like that, right? Then you've got specialized tools like Data and Data Robot and things like that, which are trying to be low code, no code types of approaches to managing machine learning and things like that, right? And then you have sort of, notebooks and Hex and Jupyter and things like that. And, really more like, hey, you should learn Python, and Python's easy. Python is accessible, right? As sort of the third category here. Do you see that one of these categories is going to kind of take over, or do you see that there's space for all three of these as data science gets more accessible?
Yeah, Tim, I think that's a really interesting way of putting like kind of the three categories. I never really thought about kind of the categorization of these, but I think that is correct, that like, hey, one is kind of the low code, like low code, no code tool, and then enhancing that with, Python capabilities. We saw that with like the Microsoft Excel feature with Anaconda, right? The fact that you can actually run these Python, formulas, or these Python sort of procedures within Excel. And then also kind of your typical, like I think of Data Robot and Data IQ, maybe Alteryx maybe also falls into that mix of like maybe an auto ML tool, but also it's doing a little bit of data prep. It has a little bit of some of the capabilities that you would expect from like a data platform. And then kind of the notebook, which I still think that notebooks is still focused more on like the programmatic audience. When I say programmatic, it's, you're writing code to do something to your data. You're not doing point and click and so on. Now we are seeing kind of the blurring of those different lines with, like, for example, Hex has a really nice interactive sort of panel that you can actually look at a dashboard that is based on your notebook and so on. So I do think that we're seeing a blurring of the lines across these three categories, dashboards to automated tools like AutoML, and then and notebooks and so on. And I think it serves different personas and audiences. And one of the funny things about like data tooling is that I think if you try to pack too much in a tool, you never please everyone. And so I do think that each of these like categories of tools serve their specific markets very well.
I think that's a very astute answer, and yeah, it's pretty hard to build a spreadsheet BI notebook auto ML tool, right? That's just, the scope is too large, and how would that user experience even work anyway, right?
And they're different personas, different users. Like,
yeah, exactly. Yeah.
So one of the things that, looking at these three categories, I'm surprised, or actually, where does like SQL fit into this? And I want to broaden off the question, is like we're talking about data science, but then also where does data engineering fit into this? Because I feel that there's like so much overlapping work that occurs, right? You said it earlier, it's like, oh, data scientists, like they clean the data. I'm like, well, isn't that something that now the data engineer is doing? And like, all that work is also happening in SQL, but they don't. But then people do, the data scientists go do all this, write all this Python code where you're like, all you just did was a join. Like that would have been like a SQL query. Like, so we both talked about these three categories. I'm like, so where does SQL fit into all of this? And then how does the data science work fit into like the data engineering work, and how are the lines getting blurred over there?
Yeah,
that's a broad. I just dumped a bunch of stuff at the same
time. So in terms of like Python and SQL, I mean, SQL was developed like when relational databases were developed, right? It was developed because people wanted a declarative way of saying, this is what I want to do with my data. And then I have this very intelligent query optimizer that figures out like a query plan and actually figures out a plan to execute it on my database. That's why SQL was developed in the first place. It was called structured query languages. And SQL is designed so that it had English phrases in it, such as like select and from and where. So those were like English-like clauses. And it did really well, right? Like people were able to use SQL. Data analysts, data engineers over the past 2 or 3 decades have been using SQL to work with the data in their relational databases. I think one of the reasons why Python and other languages also rose over time was the fact that, one, not everyone puts their data in a relational database, right? Like, data can be in spreadsheets, it could be images, it could be documents, it could be all sorts of different things. And if you can't fit it into a relational database, you can't use SQL on it. Now, the second reason why like Python has also gained in popularity is also the growth of like machine learning, and sort of machine learning and other kind of advanced data science workflows that people want to do with their data that traditionally would not fit very well in the SQL type of world. Now, I think we are starting to see a blurring of the lines here, with a lot of like cloud data warehouse companies actually offering Python native sort of APIs and solutions on top of their databases. So even today, like if you're a Python user, it's not just about, if you have your data in your database, you don't have to write SQL to be able to work with the data. Like maybe you're a Python user. And the reason why we're seeing this shift in the market is, if you actually look at the growth of these programming languages, like Stack Overflow does this survey every year where they survey data science, they survey like, I think basically people like, I think programmers, I can't remember exactly what's the population here, but it essentially Python, this was, I think this year or last year was the first year that Python took over SQL as I think the third most popular programming languages. So both of them are hovering at around like 48, 49%. So basically like 1 in every 2 developers are using Python or SQL. I do think
how is that? Python and SQL are right neck and neck right now.
Right. Yeah. Right.
What's number 1?
I don't know actually.
Okay.
Yeah, look it up quickly. Okay, so at the end of the day, like the lines are fully blurred here. At the end, it's like you just work in data. Like, and what does that mean? Like, well, everybody's definition of data is going to be very different. Like, I may call myself a data engineer, right? But I'm kind of doing already some work that, and somebody else are calling themselves a data scientist, right? So I think like that all these roles and titles are just being very blurred. So that's an observation here out of this conversation.
Well, I think my hope is that like I hope that in like 5 years or 10 years, the language that you pick doesn't actually limit you to what you can or cannot do with your data, which is like true today, right? Where like, hey, I can like, okay, like even without kind of the Python APIs on like databases, like the Python stuff all lives in Python land. All the database stuff all live in database land. And like my hope is that in the future, like there are APIs that are sort of agnostic to whatever like backend your data is stored in. Maybe it's a data lake, maybe it's a database, maybe it's something else. Maybe it's a bunch of unstructured data or something like that. And you can use Python. Maybe if you like SQL, maybe you like, Julia or whatever is your programming language of choice, you're able to work with that data. And then the platform just like figures it out for you, right? Like figures out like what needs to be done to your data. That's kind of like, to make data truly accessible, that's kind of where we want to be.
Well, I'm gonna put my same hat as always, and I agree with you. I'm like, at the end of the day, like this shouldn't be like, oh, so if you're gonna go use tool language or whatever, you got to do it this way, and then because that's how we generate silos about the stuff, right? So it's just like it doesn't matter. Like at the end of the day, just use the tool that is most comfortable to you, but for it all to work out, like the data needs to have your well-defined meaning. This is where I think the semantics are going to play, and the knowledge and all this plays an incredibly key role in order to accomplish that vision. Anyways, that's my perspective. I'm curious what you think about that.
Yeah, I definitely agree, and I think a lot of the work around like data discoverability and obviously catalogs and others is important to like enhance your data with that semantic information, that semantic layer. I think there's a lot of exciting work, cutting edge work that's being done like over the past couple of years and like nowadays on this front.
I'm looking at the question here that Malcolm has, and this is the type of work. So you're saying like, what you have data scientists who are like, are they using the outputs of these existing data management tools? So like, oh, tools that are already doing master data management, they're doing data quality, they're doing all the semantic and stuff. Or are they like taking it from the source and then they're doing that themselves, that work, and maybe even repeating it over and over? Like I see, I mean, I see both sides,
bit
kind
of
of
both,
a
yeah.
little bit of both. Like, again, what's your perspective? Like how do you see this today, and where should this go?
I think it's a little bit of both. Like, definitely, it depends on the workflows of like the data practitioner. It depends on the organizations that they work with and what workflows they have. We do find that a lot of data scientists like to use their own tooling, but also oftentimes like that is dictated by like, hey, like what warehouses are all your data stored in, or like, hey, what's the typical workflows? So I think it's a little bit mix of both. And I think for the data engineering use cases specifically, we do see a lot of like people writing data pipelines and scripts to pull all of that information together in house.
Yeah, that makes sense. One other thing, Juan, you brought up was data science versus data engineering. And I'm wondering, is when we talk about making data science more accessible, are we also talking about trying to make data engineering more accessible? And Doris, how do you feel about how those two fields are evolving, together? Is this another area where the lines keep blurring?
Yeah, I think traditionally, like data engineering has been focused on sort of the ETL use cases where I'm taking my data. I have to do like some sort of transforms operations, typically in SQL, and then get it to a format that is clean that my BI analyst can plug in their Tableau and like look at the data. So that's kind of your typical workflow. Now a lot of things are changing because of like what that kind of this trend towards like the modern data stack, where you have an entire sort of stack based on data that is in your warehouse. And so I think some of that is evolving, but I think that between like data engineering and data science, one of the primary use case, like one of the primary like handoff process that we do see is that a lot of the times a data scientist would go in, they would develop some sort of, let's say a fraud prediction workflow based on some machine learning package. Now, this would be developed on a Jupyter notebook in like maybe a single node on my laptop, and it works. It's like, okay, I have like 98% accuracy. I'm done for the day. But now a data engineer needs to be tasked with the job of like, hey, I need to now take that notebook, translate it into something like Spark, or like rewrite it into SQL, or something that is a little bit like more robust, so that we can actually deploy that workflow into production pipelines. And that friction point is something that we see a lot, and it's a huge pain point, right? Obviously, because you're doing the exact same work, but you're kind of having to retranslate or rewrite those workflows into what they're calling like a more robust language. And so that's one area where we've seen like that data science to data engineering handoff process being pretty high on friction.
This is a very interesting point you're bringing up, and what's going through my head is the way I see this is like data engineering is run, as you said, like the ETL, ELT, whatever ends up in your database, data lake, all that stuff, and then you want your analyst and also your data scientist to go find their data to go do their stuff, right? So then they go find the data and they go do the work as you described. And they're like, okay, I'm done. I did it on my laptop. But then there's like this cycle that it goes back saying, okay, now we need to put this into production. But this isn't just about data engineering. Go add it back to the data lake. I mean, it could be something like that, right? But it also, I think, kind of now the follow-up question is we talk about data science and data engineering is like, so where does the data science and the ML engineering come in? Like, I mean, there's all these cycles that go around. So first of all, the point I want to make is like, it's really interesting how you're bringing up that the output of a data scientist after they've done their work that comes from the work that a data engineer did, the output of data scientist goes back inside to the data engineering, and you have this circle and there's that friction there. So that's a great observation. I never thought about it that way. So thank you. But then that also leads me to think, it's like, so where do these ML engineers now go in, and where's the friction with all the data science and data engineering and ML engineering and whatever more roles we're going to come up with.
Yeah, I think the use case that I referred to earlier probably is closer to what one would call a like a machine learning engineer at some companies. Machine learning engineers don't exist at some companies, so they're just called data engineers. So it's kind of synonymous, kind of in that realm. But the idea there is like someone needs to take these models, these pipelines, and put them into production so that they can be served, run in a scalable manner.
Here's an overly simplistic question for you. You're growing a new data team, right? Are you going to hire a data engineer first or a data scientist first?
I guess my question is what kind of data team, right? Because it depends, right? Is the key challenge of, let's say I'm building a product or I'm building a data-driven product, is the key challenge here or the key innovation here like a model breakthrough, like a breakthrough in how we can do the modeling on this specific type of data? Or is it we know what the model is, we know it's a very simple task, we're able to replicate this, but we need to serve it to a billion customers? So that's kind of the two questions I would ask, and that fork kind of determines like that team composition and who do you hire first and what is the roadmap going forward.
So the more novel it is that you're trying to do or discovery driven, then you may need, I mean, it depends on what kind of problem you're solving. On the more simple side, it might be an analyst. On the more complex side, it might be a data scientist or a machine learning engineer, something like that, right?
Yeah.
But like if let's just say you're like, I've got customer data over here and I've got, customer data over here and I want to combine it together and I want to stick it in Snowflake so I can make a dashboard. Well, then maybe you're talking a data engineer or something like that, right?
Yeah.
All right. So like, I guess, so the point is that probably you're always going to start with more on the data engineering side because you need to kind of do the basic stuff first. And then later on, you're always going to have a data science. I mean,
well, I don't know. Now I'm mixed on that because the other takeaway I took from you, Doris, was that like a lot of times the data scientists are the trailblazers, right?
Well, it depends on how clean your data is and where it sits, right?
Yeah, well,
that's another T-shirt for the store. It depends.
that one. It depends. That's always actually that's a call out to our good friend Sanjeev Mohan, which his show is called It Depends, because you know what, that's probably the answer to most questions. it depends, and it's hybrid, right? It's a hybrid role. It's a hybrid structure. You do. Well, so I'm curious, you've worked a lot of the open source world. What is the market of data science tools evolving? What's coming up next, and what's the role of open source around all of this?
Yeah, I think open source is like, when I first discovered open source I think when I was like an undergrad in Berkeley, like I was like, wow, this is like a brand new world. This is crazy because people are developing these tools based on the challenges that they have at work or something, and they're like, hey, I'm gonna go and build this tool and it's gonna solve this pain point that I have. And these tools have over time gained such a huge community followership. I'm talking about examples like NumPy, scikit-learn, Matplotlib, these things that have become standard tooling in data scientist toolbox. They are developed by folks that just decided one day, like, hey, like I have this pain point, like plotting is very difficult. What if we had a library that made that easier? Or like, hey, numerical computing. Like I believe that was developed by either a group of physicists or a group of scientists somewhere for scientific research. This whole ecosystem of like what they call like PyData ecosystem, like a Python data ecosystem, really have helped kind of Python create these higher level abstractions and APIs for like what you want to do with your data. That might be data transformation, cleaning, in the case of like pandas, or it could be like running machine learning models in the case of like scikit-learn. Maybe you're like using stats model to compute some sort of statistics. So it's a really like amazing sort of avenue where like we have these like very rich abstractions, APIs that are created, which makes it which makes it easier for people to create complex workflows. And so we've started seeing this like explosion kind of tooling and just like open source projects. And I think you know the ecosystems like GitHub and other like community like resources that definitely help with that growth, with collaboration. And I think one of the things that I've learned over time is that you might have like 10 different tools trying to do the same thing, but usually like one or two tools win out. Like after there's like a bunch of exploration in this space, like users end up gravitating towards one or two tools, and oftentimes those are not like the most complex, the most technically elegant, the fastest or the most performant tools. It's really like what's the easiest thing to use, like what's the easiest getting started experience. And then I think the other aspect of it is like open standards. Like we've seen time and time in like in the data tooling space that open standards, open source wins out over time than like proprietary solutions, because as a data scientist, I want a lot of control and understanding of what exactly is being done to my data. Like you wouldn't want to create a pipeline where there's like a giant black box and you're like, oh, I don't really know what it does, but it like spits out like a 90% accuracy. Like that's not great, because like eventually you want to be able to tune, you want to be able to like, I think of it as like you're fixing a car, right? Like you want to understand like what needs to be done to your car, the gears that needs to be changed and everything. But if it's all like taped up and everything, then you can't make any changes. You can't optimize for the performance and so on. And so I think open source and open standards provide data scientists that sort of like peace of mind that they can always go in and make changes, make modifications, and improve on their pipelines and so on. Which is why, like, I think over time, like, open source and open standards have just like blossomed over proprietary solutions, especially in the data tooling space.
So two things. One, can you give an overview of? I mean, I think the things you talked about, right? Like NumPy and Pandas and stuff. Like this is all within the Python ecosystem. Like, what are the categories within the Python ecosystem? Like, oh, I'm trying to go do A, and for A, you want tool X, right? Like,
yeah.
What does that landscape look like?
Yeah. So I think of it as like I'm a data scientist, and what's my typical like data science workflow? So typically I would start with maybe a CSV file. Let's just take a CSV file. I need to load in my data, and then I need to do some sort of transformation on my data. So for that you want to use Pandas, because Pandas comes with a very convenient data loading, data transformation, data cleaning functionalities. So you use that to clean up your data, you do their transformations, and then you're like, hey, but I need to compute some sort of statistics, or I need to run a machine learning model and so on. And then for that, the standard tool here is like scikit-learn, right? You would use scikit-learn to train and fit a model. You create your train test data, and then you run the training, you do the prediction, and then you use something like matplotlib or Seaborn or Altair, these visualization packages, to then say, okay, I have all of these model results. It's like 0 1 0 1 0 1, like it's all like binary numbers, right? Like how do I visualize it? How do you understand what's going on with the model? And then you would use something like one of these visualizations library to do that. So that's a very simplistic view of like kind of an end-to-end workflow. Obviously, depending on like maybe you want to use more complex models, maybe you would want to use like XGBoost for training your decision trees and so on. So there's all these forks between the two, but that's kind of the overall like a very simple workflow.
This was very clear, and I thank you for that. Right, I think it's like the transformations, or just loading with the data, being able to go do all your statistics with all the models, and then actually some visualizations. So those are the three main ones, right? What are other ones that are like smaller nuances, corner cases that people can start once they have like they've mastered those three? Like, what are the next ones after that?
Or also, how do you think of like things like Jupyter and stuff like that? Are those like platforms where you can execute these things? Is that kind of the way you think of that?
Yeah, that's a really good point, Tim. So I think of these libraries that I just talked about as like packages that you would import. So I think of, like in a very like layman's term, it's like special skills, right? Like I import these special skills, and now I can do visualizations. Now I can do like statistics and so on. For something like Jupyter or like IPython notebook platform, they're more of like the IDE, so that a development environment. Think of these as your code editors, but obviously a lot more interactive. So think of them as like your Sublime Text, your VS Code, and so on. And it allows you to basically create a narrative around your story using code. So you do exactly what the workflow that I talked about, which is I load in my data, and then I maybe like write that in a cell. I like print out my data frame, and I look at, hey, this is what my data frame looks like. It has 5 columns, it has 100 rows, and it allows you to kind of iterate. I think of it as like a playground, right? You're playing around with your data, and then eventually you create a model, you print out your visualization, and all of this is embedded in the same notebook. So even when you print out that visualization, it's on the same page as you're writing your code. So that's kind of how I think about it's. It's sort of an orthogonal direction compared to the different packages, even though it is considered a Python package.
What about other specific kind of what you asked, like long tail libraries or any interesting libraries that maybe aren't as popular as Matplotlib and things like that you'd be like, you need to be paying attention to this?
I think there is like a huge long tail of like sort of Python packages that are very specific to specific use cases. Like there was one that I used during like my astronomy days. I think it was called like AstroPy and YT for like for I think like displaying like astronomical like fluid simulations details. There is GeoPandas, which is really popular for like geospatial data analysis. There is a whole slew of like long tail of applications out there. I think there are also ones that are very specific to like genomics and biology and so on.
Thank you for going for this. It was very clear. And I think hopefully for listeners who are just like, well, this is for those folks who are like, I'm trying to get into this and trying to understand, like, help me understand the landscape. This was very clear about that. But we can keep going on, but like we got to start wrapping up here. Let's go. Let's dive into our AI minute. You got 1 minute to rant about AI. Anything you want. Ready, set, go.
Yeah, I think the one thing that I would say I hate about AI, but it does like keep me up at night, is I sort of wish there was less like hype and like buzzword around like how we talk about and like describe the technology. I come from a family that is really far removed from tech, and I kind of wish that there was more explaining or like educating, helping people understand like what AI is and what it can and cannot do, so that we can start to have like real conversations around what AI can be used for.
I like that. I like that answer. I think it's part. Yeah, there's so much hype, and we need to also kind of bring it back down to reality, and this guy explain it in non-hypey tech terms.
Yeah.
All right, so let's go to our lightning round. We got a couple of questions here. I'll kick it off. So if you're just graduating from high school and you want to do data science, just data work, like, should you get a computer science degree?
I mean, if the vision that I just talked about earlier what is true, then I hope that you don't have to get a computer science degree. I hope you can pursue whatever you are interested in and love, and you will still be a data scientist one day because you'll work with data and apply it to your domain.
I like that. Second question. One of the key aspects of statistics that I think about when you're talking about, hey, how do we take some of the statistics complexity out of data science to make it more intuitive? One of the key aspects is around like bias and understanding how models introduce bias and things like that. Do you think that's something that can be automated? Like that's not something that people are going to have to worry about all the time?
Yeah, I think that in terms of like biases and like explainability of models, I do think that there's been a lot of work around, sort of being able to automatically explain or like showcase some of these like potential biases to users. I do think that education is a big aspect of like how we talk about these models and the results that comes out of that. And so I think within a lot of the branches of like AI explainability and the way that people talk about that, I think have like being able to convey that right like user model and the right model of like, hey, this is like, it doesn't like if a model says like 60%, it doesn't mean like, let's just call like a cancer diagnosis model. Like 60% doesn't mean like 60% chance of like you having cancer or something. Like there is a lot more subtlety around what the, black box is doing and the ability for us to convey like, what does that actually mean for the end user?
Yeah.
All right, next question. So I'm on the education one. So you're getting into data, right? What should you learn first, SQL or Python?
I'm a Python person, so obviously I'm a little bit biased here, but I do think that Python is a great tool because it has a low floor, but it has a high ceiling. There's so much you can do with it, but it's easy to get started. And so I think that Python can take you really far in terms of like just getting your feet wet, learning programming, working with your data, all the way up to like creating an advanced machine learning model, deploying your models, and so on. So obviously a very biased take on this question.
I think we got,
and supported by evidence.
Yeah, and I think we got Doris's quote for a T-shirt. Yeah, this is one of our dreams. Is like every single guest will have their T-shirt with their quote, and I think Python, low floor, high ceiling. That would be your T-shirt.
I would get that T-shirt.
All right, nice. We'd have at least one sale. All right, all right. Fourth question, final question. As data science becomes more accessible, will we have less data scientists because data analysts and stuff are doing data science?
I don't necessarily think so. I think it's the same like argument as is AI going to eat our jobs? I think we're all going to become a lot more productive with like AI and like co-pilot style sort of assistants and things like that. We're going to be able to do more on the stuff that actually requires our domain expertise and thinking. And then the stuff that is like less fun or like more, I guess like mundane or like repetitive gets to be automated away. So I don't necessarily think that there will be less data scientists, but I do think that per data scientist, we will become more productive.
I like that. Yeah.
You got great answers. Like it's not that these aren't like trick questions or anything. They're like just curious, and you actually have
therapy questions.
No. All right, Tim, takeaway times.
Oh my goodness. So I'm going to do the best I can here. So we started off with like no BS. How are we going to try to make data science more accessible? And you've mentioned that data science has started off pretty complicated, right? There was a lot of tooling involved. It wasn't very standardized. Usually you needed to be an expert in the domain, be an expert in statistics, programming, big data, machine learning. Basically you have to be this unicorn with a PhD. And yet somehow this was the sexiest job of the 21st century, right? It's just the 5 people who could do it, right? So there was this high barrier to entry. It's now really shifting the lower bar, and in general, the bar continues to lower. And the question becomes, how can we enable anyone to do data science and understand what's going on with their data, which is really great. And you specifically mentioned, especially domain experts, like people who understand their particular problem or market or use case or industry. How do we empower them with the tools of data science? We talked a little bit about the spectrum of data science to BI, and you mentioned that accessibility is kind of the same spirit across this spectrum. We want to get more people access to use the data. Low code, no code is a way to lower that barrier. Spreadsheets are an example of something that exists today that did a great job at trying to lower the barrier with data. Tableau is a great example of trying to lower the barrier around data visualization and data analysis. So this shows you kind of what now we can replicate as we go forward with additional tools, and a lot of great tools in open source and in the proprietary market are doing that. What's the definition of a data scientist today? Well, you said that the line is kind of blurring between business analysts, data scientists, machine learning engineers, where now, a lot of people, almost anyone could be a data scientist, no matter your role and your title. And you gave a great example where, there are spreadsheet users at banks, quants, right? Learning Python so that they can do time series forecasts and do summarization and do other types of modeling, which is really great. And what's driving accessibility? Well, it's the need to know. So it's education, right? But it's also the tooling and the technology and how that's helping as well. The programming aspect is especially an area that's getting a lot easier here. You don't need a computer science degree, right? You mentioned data science boot camps and things like that. Anybody can go and they can learn Python and they can start to do some of this stuff, and it's very accessible. Low floor, high ceiling, right? Python was very accessible in general. It's a high level language. You don't have to think about memory management and things like that. So it's a great way to get started. And then we mentioned 3 different categories, sort of data science capabilities being brought into spreadsheets and Tableau and things like that, auto machine learning tools, auto ML tools, and then Python notebooks, things like that. And you had mentioned that the lines are kind of blurring across these things, but they probably stay distinct categories because they serve different personas, which I think makes a ton of sense. Juan, what about you? What were your takeaways?
I think the blurring the lines is like a big takeaway. It's kind of across everything. Again, Python and SQL, there's some blurring the line between them, right? I mean, if we think about the origins of it, like SQL is designed, right, to have, it's a declarative language, right? You talk English phrases in there, and you have to worry about how things are defined, the optimization, and so forth. Python, well, not everybody has their data in their databases, right? They could just be things in docs and spreadsheets, semi-structured stuff. So where you actually can't put everything in SQL, and again, also machine learning, all these things. But again, the lines here are blurred because you can now use Python to query databases. You can use SQL to call script functions. So it kind of goes both ways here. And the hope is, I mean, your hope is that in the future, they're just going to be APIs, right? They're agnostic to what the data backend is. And as a user, you can just speak whatever language you want and then go execute it. And the backend will just figure it out for you. But I think we've kind of agreed on this, is that to make that vision happen, like this is where semantics and knowledge really play a key role here. Another area which is blurring the lines. I think this is what the episode would be called, blurring the lines. there's a song, right? Data science and data engineering, right? The data scientists find the data, they do their work. Okay, I'm done. What happens next? We got to put into production. So you stick it in the data lake. How do you create a robust pipeline around this, right? There's a lot of questions need to be asked. And I think data science ends up kind of doing that trailblazing work. And once they figured it out, the data engineering will come in and they need to kind of lay the roads here. And also, depending on some works, it's that data engineer is actually the ML engineer and so forth, right? So this is kind of where they go back and forth together. And if you're starting a team, like we were discussing this, who do you hire first? Again, the famous phrase, it depends. Are you building a model that to have a big breakthrough, or are you just trying to take an existing model and make it more robust? Are you building out a data pipeline on more predetermined models? This is the type of question you need to go figure out. And I really like how we ended up kind of going through this open source kind of market and how things exist here, right? You have scikit-learn, you have NumPy, Pandas. Like these are things that have evolved from folks saying, I have this problem. What if I can make this a little bit easier? And often there's a lot of people trying to create different tools, but at the end of the day, right, there's only 1 or 2 tools that will win, and they don't always have to be the fastest, the most powerful. It's like the most easiest and the most intuitive, which helps people get the most accessible to it. Open standards and open source, that really provides that peace of mind for folks so they can really kind of understand what's happening underneath the hood. And we discussed the landscape, right? You have all these libraries, the packages you can import, right? The skills you can get by just importing these packages. And you broke it down to like the 3 main ones, right? I need to load data and transform stuff. That's where pandas come in. I need to compute statistics, do machine learning models, right? That's where scikit-learn comes in, where you can do training the models and so forth. And then I do some visualizations, right? The results of that. And then you can go to the long tail about things like GeoPandas and then things that are very specific to your particular domain. And then in addition to the libraries, you have like your IDEs, your development environment. That's where like Jupyter notebooks and stuff come in. Whew. How did we do? What did we miss?
That's a wonderful summary.
Well, as always we say, this is just us repeating what you said. So thank you so much.
Thank you.
Well, just to wrap up, 3 final questions. What's your advice about data, about life? Who should we invite next? And what resources do you follow?
So first question is the advice. I think like outside of data, I know it sounds trite, but I really am a big believer that, if you set your mind to something, if you set your heart to something, there's really nothing you can't do. I think sometimes we often grow up in these like boxes or expectations around like what you can and can't do. So I think once in a while, like we all need to kind of take a step back and like just take a chance on things, and you might be really surprised by what you learn about yourself and everything.
I like that.
Agreed.
And then the podcast guest, right? Podcast guest. Actually, I think Shreya Shankar, who's really big. I don't know if you follow her on Twitter. She has been doing a lot of really amazing work on the ML ops and nowadays LLM ops space. And so definitely check her out. I think she would be a wonderful guest on the next episode.
She's doing her PhD, or she's
doing her PhD in the old lab that I was in
Berkeley. Okay, I've been following her. I agree. Okay, awesome. If you know her, I guess you do know her. Well, please connect us.
I'm happy to set.
I would love her. Yeah, I've been following her. So yeah, that's
awesome. Yeah.
And then wrap up. What resources do you follow?
This is also not data related. So when I was wearing my founder's hat, I listened to a lot of in-depth podcasts by First Round Capital. They basically invite guests from early stage startups or startups that have now become big unicorns and so on. Basically, like startup operators, leaders, founders in this space. And they're pretty long episodes. They're like 1 hour plus. I found it pretty insightful to just learn from the stories and lessons that these people talk about in building their own company. So that's one podcast that I love.
Well, I appreciate you bringing a diverse kind of different points on from advice to the podcast and stuff.
Yeah, that's awesome.
Well, Doris, thank you so much. This was a phenomenal conversation. Something that I appreciate that we haven't had a good data science and Python conversations here at Catalog and Cocktail. So thank you for that. Really appreciate it.
Mm-hmm.
Yeah, thank you so much. I really had a lot of fun on the podcast.
All right.
Awesome.
Cheers.
Cheers, Doris.